Okay. Hello, and welcome to a video demo. This is going to feature Helix a little bit, but this is going to primarily focus on a prototype platform that we are building here at ZKX Solutions. It goes by the name ZKX Calyx. What Calyx is it's a continuous digital identity authentication and access management platform specifically designed for NPEs or non-person entities. In this case, we're going to be picking on something that goes by the acronym UAS, or Unmanned Aerial or Aircraft Systems. And we're going to show you how we can use those patented ZKX Solutions processes to have a more data-driven and more in-depth look at how to not only measure the cybernetic integrity of our unmanned assets, but then also make decisions based on the results of those measurements. So I'm sharing two things with you right now. On the left-hand side, you're seeing the Calyx Orchestrator platform. You can maybe see in this top left corner, I've got a little picture of a quadcopter drone. I want to emphasize that for the purposes of this prototype, this is not just a fun animation object or a script that's tied into this web backend. This is actually the software that would run on a physical UAS platform. So this is effectively like the digital brain of a quadcopter drone that we're actually going to be playing around with here this morning. Um, on the right-hand side, we are going to incorporate elements of Helix into this demo. It's going to be very brief, but because Helix is involved, I am sharing a screencast again of a phone that I have here just on my desk. So we'll actually go ahead and use that phone right now. Calyx works in two capacities. It works by authorizing the operator, the human in the loop that wants to issue commands to these unmanned platforms, and it also works by authenticating and re-verifying unmanned platforms that you may lose connection with or something about their state might change. But I'll show you the operator component first, where if I'm the operator in this situation, I'm going to request to initialize this particular endpoint. You'll see this MFA push come through on my companion phone. So, hey, was this you? Are you on the right device? Do you have the right privileges to authorize this unit for initialization? I'm going to go ahead and say yes. This is also going to come with making sure I have my RFID NFC readable card with me that's bound to my identity somehow. So that's all well and good. You can see on that left-hand side, my drone has been initialized. So again, I'm going to hit this takeoff button. If I had a drone plugged into my lab system here, you would see it actually start to rise. But again, this is just lab demo. It's just software at this point. So we're going to go ahead and hit that takeoff button. And that drone it's pre-configured to hit 10 meters of altitude. It's going to climb. You can see those numbers going up now to that 10-meter mark. So I now have, as the operator, privileges to do a couple things to this drone, right? I can have it land where it's at, I can have it return to the launch point, but more importantly, to showcase the drone identification and re-authentication phases, I'm going to hit this button that says simulate disconnection, right? Which is not an uncommon thing to encounter, especially if I'm forward deploying this thing to pursue some kind of mission objective, right? Go take a photograph of this area or record video of this person, right? So I'm going to have that the disconnection rather, be simulated here. And I want to point out this panel on the right-hand side. So I'm measuring different components of this particular UAS system. So what I have measured here are a serial number for one of its components that's on board, something about its firmware integrity, an attestation of its boot sequence, measuring its network posture, and then also some data I've loaded into like a secure memory partition that runs on this particular endpoint. So what this actually does under the hood is that all of these values we can measure from this endpoint when it comes back online. These measurements are then fed into that patented ZKX process, which for all intents and purposes effectively acts as a key derivation function. The derived key is then used to drive these zero knowledge proofs that tell us whether the key that was derived was the correct key or if it was something different that we weren't expecting. So in essence, if any of these values are to change in some kind of discrete and measurable way, just through the mathematics alone, again, there's no agent running on this thing that's doing health monitoring or some kind of weird comply to connect thing. Just purely through the mathematics of how this works, I can start to get that composure measurement of, okay, what of my drone, if anything, may have been compromised while it was disconnected. I'm going to go ahead and reconnect the drone here, and we're going to see that because I didn't tamper with any of those elements, right, all of those zero knowledge checks have passed. And it's important to emphasize that this is a zero knowledge check because if something were to contact this drone and try to pull that data out of it, saying, hey, what's your serial number? Or what's the measurement for your network posture right now? Zero knowledge ensures that even if an adversarial C2 component was making that request, it would never learn what those actual values are, right? Just if they're accurate or not. So what I can do here, right? Okay, all my systems passed. That's all well and good. The operator, me in this instance, didn't have to be involved in that discussion. But in order to get me involved in that discussion, I'm going to simulate another disconnection. And let's say that an adversary does gain some kind of illegitimate access to my endpoint here. We're going to hit this button that says simulate compromise. And what that does is it actually reaches into the software of this drone and changes these two values. So if you remember my explanation from before, these two measurements of these components of my drone, again, across both hardware and software dimensions, are going to derive different keys now. Those different keys will not be able to pass the zero knowledge proof check that then drives the rest of the status and security posture measuring. So when I reconnect this drone, you're going to see that I have had identity verification for this UAS fail. And it's failed on the basis of that serial number and then that hash of the firmware that we were measuring. So, maybe somebody got in and it's trying to have it take some kind of nefarious action, right? I have two options here as the operator. I can override this security measurement, say, you know what, I understand that maybe it's kind of compromised, but maybe not to a degree that's total mission failure, right? Maybe I want it to continue to pursue its mission thread and go execute what I originally set it out to do. So I, the human in the loop, have chosen to override that particular security notice. But let's say that I'm going to simulate another disconnection, and now I'm going to simulate a different compromise. Maybe now that my memory integrity, right, you can see here, is the item of suspicion of that measured failure, right? Again, the measurement has changed, therefore the mathematics have changed, therefore we have that visibility into the changing of the security posture. Maybe I, the operator, can decide, okay, this is an unacceptable level of risk to the mission that I'm trying to execute, and I can hit this neutralize button. And so that could mean a couple things, right? It could mean that I just went and zeroized the operating system, or I issued it some kind of kill command, or I changed its flight trajectory to just go over the ocean until it runs out of battery, or maybe I just sent a command to my fire system and just made greenlit it as a target, right? It could mean anything in the world, but the important thing is that I was able to make a data-driven decision that was risk-based and measurable about these physical components of my UAS. Again, just UAS for the purposes of this demo. Calyx we can apply really to any kind of NPE, whether it's an unmanned aerial system like this, a submersible, or even like a VM or an AI agent, right? The idea is that if it's an autonomous operator on your network, we certainly can do better than shared secrets or RF links or X509 certificates, right? So that's the essence of the demo. Again, just one of the other projects we're building here at ZKX Solutions. Really appreciate you hanging out with me for a long video this time. But as always, if you've got any questions or just want to tell us how great we are and how cool the things that we're building are, feel free to reach out to me or anyone on my team. We'd be more than happy to have a conversation. Thanks.